We'll come back to that. Let's flip to the next page. Bottom of the next page, please. Nope, middle, top, just the next page. Top of the next page, sorry. Okay. Some notation for you. Everybody loves notation. Okay. So we've talked about inverses, right? We did inverses on Friday. What do you do when you're doing an inverse? What does that mean? If I say graph the inverse, what do? You switch the xy, right? Okay. So there is a notation to represent the inverse function, okay? And that is, well, there's two of them, but this is the one you're going to see most often. F to the minus 1, okay, means the inverse. That's what, if you see this, it means inverse, the inverse of x. Now, there's another way that they write it. It's not often that you will see this, but I will probably put it on a test just to confuse you, see if you understand. And it is this. X is equal to f of y. Why is that the inverse? What's the first? What do we do when we do the inverse? You switch x and y, right? So if we have y is equal to f of x, and I switch x and y, what do I get? X is equal to f of y. Okay, so that's all it is. So both of these represent the inverse. This is the one you usually see. Okay, but just be aware, you might see one of these. We okay? All right. All right, I just need to talk about this. In grade, I don't know what grade, 10, 8, 4, I don't know, whatever grade, you probably saw this. If you have a negative exponent, it means 1 over the number, right? Yes? If I have x to the negative 2, that means 1 over x, okay? That applies only to numbers, all right? Not to functions. If I write f to the minus 1, it does not mean that. This is a little equal sign with a slash through it means not equal to. Okay? This is the inverse. It's you switch the xy values. This 1 over f of x represents the reciprocal. We'll talk about that later on. Okay, so if you see f to the minus 1, do not write 1 over f of x. All right, so just a quick review of what we did on Friday. On Friday, we were finding the inverse equation. And we did one on the quiz today. So we can do, we'll do B. F of x is equal to x cubed plus 4. What do I do?
Instead of y equals 2x minus 3, you switch.
We're going to.
X equals. Oh, that one. Was not.
That's okay.
Put the f of x, which is y.
Yes. Yes. So f of x is the same as y. And then you switch the xy values. So I get x is equal to y cubed plus 4. Now you got to solve for y. So what do I do? And now what? Stuff we talked about. What do I do now? When you're cube rooting, do you have to put a plus or minus? No. Because it is an odd root, right? There's only one answer. If it was a 2, you would have to put a plus or minus. Okay? So y is equal to the cube root of x minus 4. Then you can write, I know it's a function. You can say that it's f to the minus 1 of x. You don't have to. If you want to, that's fine. Is that okay? Any questions about that? I know it is because I know what the graph looks like. You don't. You'd have to see the graph, basically. Well, and it doesn't have a plus or minus on the outside, so, right? That's one way, but I don't expect you to know that unless you had a graph, and then you could say it. Come on. All right, next page. This is like something you would get on a test. So consider the function x squared minus 4. What type of graph is that? It's a parabola. Yeah, it's a curve. Does it open up or down? Up, because it's a positive x squared. What does the minus 4 do? Moves it down 4 units, right? So these go by tens, or by twos, sorry. So negative 4, it opens up. That's the graph of x squared minus 4. Okay. We've done that. We need domain and range of this graph. Do we remember domain and range? I saw some people did it on the quiz. That was awesome. I didn't ask for it, but that's okay. What is the domain of this graph? First of all, when do you have domain restrictions? I gave you 2 options of when you have domain restrictions. Does anybody remember them? When you have a square root, because you cannot square root negative numbers. Is there a square root in this equation? No. When's the other time? When you have a variable in the denominator. So basically, if you have like a root x or something, or you have an x in the denominator, because you can't divide by 0, then you have domain restrictions. We don't have either of those, so do we have any domain restrictions? No. What do we write if we don't have any domain restrictions? All real numbers? Yes. So 2 ways to write that. You can write it like that. X is in. Do you know what this E-looking thing means? Anybody? In the set of, right? In the set of, and then R is real numbers. Or you can write it with the interval notation, which is negative infinity to positive infinity. I don't care which method you use. What's the range of this graph? Greater than or equal to negative 4. So you can write y is greater than or equal to negative 4, or negative 4 to infinity. Do we include the negative 4? So what kind of bracket do we put around it? Square bracket, and infinity you can't get to, so you put a nice round bracket, right? Okay. Is everybody okay with that? What does this mean? Inverse. Okay. We got to figure out the inverse equation of this graph. So, x squared minus 4. That really means y is equal to x squared minus 4. What do we do? Switch x and y, right? Y squared minus 4. That's a big 2. And then solve for y. So move the 4 over. Now what? How do I get y by itself? Square root. What do you have to remember when you square root? Plus or minus. So we're going to square root both sides, and I'm going to get y is equal to the root of x plus 4 plus or minus. Cool? Okay. Now we got to sketch that graph. So I'll do it in, I'll leave it in purple. Okay, just ignore the plus or minus for now. If I gave you the graph of x plus 4, what do you do to sketch it? What makes the inside 0? Negative 4. So you go to negative 4. which is right there. Does it open to the right or to the left? And how do you know? It goes to the right. How do you know? X is positive, right? Correct, I should say. So now the plus or minus comes in. So if I've given you, you don't need to write this down. If I gave you that, you're at, whoops, sorry. -4, you know it goes to the right. Everybody would draw that, correct?
Yeah.
Okay. That's because it's a positive out here. What does the negative tell you? Sorry? Doesn't open the opposite way. What do you mean by both? Like, you mean like it goes like that? It goes down. The negative will open it down, right? Yeah. So when you have the plus or minus, it means it looks like this. There's the positive, and there's the negative. And that makes sense if I just gave you the graph and I asked you to sketch the inverse, you'd switch the xy values and it would turn it on its side and you'd get both. Okay? Now, for the purple, so the purple is the inverse, f to the minus. Oh, actually, is this purple graph a function? No, because it fails the vertical line test. Remember the vertical line test? If you draw a vertical line and you hit it twice, then it's not a function. So I can't write f to the minus 1 because it's not a function. F means function. So we're just going to say this is the inverse. We're almost done. Okay. Domain and range of the purple graph, please. Domain, range. What's the domain of the purple? Dx values. Yes. So we start at -4 here, and they get bigger going to the right. So you can say x is greater than or equal to -4, or you can say -4 to infinity. Does that make sense? What is the range of this graph? Sorry? The range? So you start here. I mean, these actually go up. I look like they flattened out. But basically, they just keep going up forever. So it's going to be all numbers, right? All real numbers. So it's going to be YER or negative infinity to positive infinity. Okay, here's your question. Oh, come on. What do you notice about the domain and range of the original? They have switched, all right? Which makes sense because you're switching the xy values. So the domain of the original, which is all real numbers, becomes the range in the inverse. And the range of the original, which is greater than or equal to -4 and -4 to infinity, is the domain in the inverse. So when you do an inverse, the domain and range switch. Okay? And last question for today. So hang on, just say domain and range switch. I'll just say in the inverse. Okay. And last question. Is the inverse a function? We've already said that. No, because it fails vertical line. No, because fails. VLT is vertical line test. Okay? I'm too lazy to write out vertical line tests. But how could you change the domain or range so that it is a function? That's the question. What can I do to the purple graph to make it a function? I.e., I need to eliminate one of those dots. What can you do? There you go. You either just cross out that one or you cross out that one. And then it is a function. So the way you write that in math is you say restrict the range to either y is greater than or equal to 0 or y is less than or equal to 0. All right. Didn't get as far as I wanted, but that's okay. We can do that tomorrow. All I want you to do is 5 and 6, please. Tomorrow we will